All right, guys, we're going. Okay, stick right here with me, okay? Did we highlight the section that it appeared on the midterm or the final anywhere? We did? Okay. Which one? Do you know? The final? Okay. Okay, so we did talk about end behavior a little bit, okay? You guys, this is what an end behavior is. Just everybody relax for a second, don't write, okay? An end behavior is this. So as x gets really small, where does my graph go? And then as x gets really big, where does my graph go? So it's not the stuff in the middle, it's the far right and the far left, where does my graph go? So that's end behavior, okay? Okay, so y equals x, take your pencil and draw the line y equals x. Looks about like that. We're just doing approximation, okay? Y equals x to the third, you guys know that was a parent graph on that previous graph, on that previous lesson, so it looks like that. Somebody tell me what y equals x to the fifth looks like. Like compare it to the x to the third. It's the same except steeper. Yep, gets higher and lower faster. So it looks like that. Okay. Now look at these exponents, you guys. They are 1, 3, and 5. So all these exponents are odd. Okay. Now I want you to look at the left side of your graph, guys. Look, the left goes down, the left goes down, and the left goes down. So the left arrow goes to the left lower corner, okay? Now everybody freeze right here for 2 seconds and let me show you something. Look, here's a box, okay? The left side of the box has a left upper corner and a left lower corner. So that arrow that I just drew has to either go left up or left down. Those are the only two options, okay? And now let's do the right one. So this one goes right up, right up, right up. So look at that right side. I've got a right up and a right down. On this cubic, they're all right up. So there's my end behavior, okay? Okay, x to the second, you guys know is a parabola. So it looks something about like that. Somebody tell me how y equals x to the fourth compares to y equals x to the second. Same thing except steeper. Good, so we're going to be a little skinnier. Get taller faster. Talk to me about x to the sixth. Same thing, just steeper. Good. Good. Okay, here's your box right here, guys. It's going to be left up or left down. Those are your only two options. Okay, look. Left up, left up, left up. So you take your pencil and you draw an arrow to the upper left corner of a box. Okay? Then the right is right up, right up, right up. So you're going to either point up or down and to the right. So the right arrow goes right up like that. Okay? Who says I got that? Let me see. Now, some of your teachers, I think, have allowed you to do that. Okay? But you guys know a parabola never does that, right? It goes like this. So you've got to point those to those corners, okay? So please don't do that. Okay. So let's fill in this little table and then I'm going to talk just a little bit more. So an even exponent, like y equals x to the second, with a positive leading coefficient, meaning a positive in front of it. Well, you guys know that that's just a parabola that opens up, right? So everybody in the room, talk to me. Does my left arrow go left up or left down? Left up, right? So everybody go left up. Talk to me about the right arrow, all 38 of you, right up or right down? Right up. Yeah, looks like that. Okay, now what if the sign was a negative? What if the leading coefficient was a negative? Then it would be a parabola that, talk to me, opens down. Okay, everybody in the room, and you don't have to yell, you can just answer. Left up or left down? Down. Left down. And then right up, you guys, are right down? Down. Right down. Okay, so it looks like that. What if you have an x to the third? Okay, well you go, well that's odd, so I know it's going to take the shape of a cubic, so it looks like that. So my left arrow points to the left lower corner of a box, and my right side points to the right upper corner of a box. Okay, what if your cubic has a negative in front of it? Okay, answer this question, everybody. If I have a negative right there, is that a reflection across the x or is it a reflection across the y? Tell me that. X or Y?
X.
It is X. You know how you know it's an X? Because the negative comes first. Remember that lesson you had to watch on your own? Alphabetically, X comes first. So if the negative comes first, it's an X reflection, okay? So an X reflection, that little piece right here that I just highlighted will come up, and this part right here that I highlighted will come down. So then my end behavior is left up and right down, like that. Okay? Okay, jot this in somewhere, okay? Please. Write down the words left arrow, and then I want you to write down the words right arrow. And then I want you to put a box right in there, okay? So for that left arrow, you literally only have two options, okay? You guys, the left arrow always points to the left. So you're going to go like this. You're going to point to an upper left corner or a lower left corner. The right arrow, again, you only have two options. So it points to the upper right corner or the lower right corner. Those are literally your only two options. Okay? Look at this. Is that an acceptable end behavior? Is that one of the options? No, because look at my left arrow, it's pointing to the right. If somebody does that, let me show you what they're saying to me. They're saying that that arrow goes on forever, right? Over here, same thing. It goes on forever. And then I connect my pieces. So you're saying that the graph of that thing looks like that. It's not possible. Okay, so just make sure you're pointing it in the right direction, okay? All right, example 1. I want you to go like this, guys. I want you to hook those three together, and I want you to hook those three together because they're different. You're going to do them in different ways, and I don't want you to get confused, okay? Look at example 1A. You guys see the 1? It affects the graph, but it does not determine the end behavior, so I want you to get rid of it. Same thing with the negative 4x a second. It affects it, but it doesn't dominate it. So the thing that dominates it, you guys, is the biggest exponent, which is right there. So listen to what goes on in your head. You're like, okay, it's odd. Odd means it's going to take on the shape of a cubic, right? But do I have a reflection? Yes, I do. So it's actually going to flip it, and now it's going to go like that. So my end behavior is left up and right down, and I'm done. That's it. Okay, go to question B. Get rid of the 7x because it affects the graph, but it does not determine the end behavior. Look at the biggest exponent. It's right there. It's even. Anything that's even takes the shape of a parabola. Since the 5 is a positive, I know it opens up. So my arrow is left up and right up, and I'm done. Literally, that's all I do. Who says I'm totally good with this? Let's see. Great. Okay, so on the next one, biggest is the x to the 4th. That's a parabola. You guys know it's a negative, so the parabola opens down. So my arrows are left down and right down. That's my answer, and I'm done. Okay, off to the side, I want you to write a note to yourself that says, look at the biggest exponent. Now, I want you to compare like question A to question D. Just take a second and look at those. So question A, it's all multiplied out or all simplified. And question D, it's factored. Okay, so you don't have to multiply the whole thing out because the only thing that determines the end behavior is that biggest exponent. So what's my biggest exponent going to be, everybody? It's a third. Look, because you have an x to the first, x to the first, x to the first. When you multiply those, you add the exponents, and that gives you an x to the third. And you guys know that that's a cubic. and I don't have any negatives in front, so it's not going to reflect it. So my arrows are left down and right up, and that's my answer. Okay, now they do get just a little bit tricky. This one, question E, I think is the trickiest. So see this x, it's going to be raised to the third when you multiply it out. This x right here is going to be raised to the second. But what am I not writing down, you guys? Yeah, the negative is definitely going to affect it. You guys tell me, when I multiply x to the third times x to the second, do I get x to the fifth or do I get x to the sixth? What is it? It is fifth, yes, okay? So there's my dominating thing. I don't have to find all the terms. I just have to find the biggest one, okay? So this is going to be the shape of a cubic because it's an odd exponent. It has a reflection, so I'm going to flip it the other direction. So my arrows, my end behavior are left up and right down. That's my answer, and I'm done. Okay, last one. This x right here is raised to the first. The next x is raised to the second. And then the last one is raised to the third. And I don't have any negatives in there at all. Okay? So I'm going to add the exponents. 3, 4, 5, 6. 6 is even. I know that's a parabola. I don't have any negatives. So it's going to take on the shape of a parabola that opens up. So my arrows are left up and right down, and I'm done. Okay?
Left up, right up.
Left up, right up. Yep. Thank you. Left up, right up. Good. And I'm done. Okay? Okay, off to the side. Come over here and write yourself a little note. Okay? And I want you to write, add the exponents. So if it's multiplied out, you add the exponents. If it's already multiplied out, you just look at the biggest one. Okay? Okay, let's find some intercepts. Okay, this was a question on a midterm or final recently. Well, not super recently. Fill this in for me. Okay? The graph of a function can have more than one y-intercept. Don't respond yet, please. The graph of a function can have more than one y-intercept. You guys, whenever I get questions like that, I always draw a picture. Because if I draw a quick picture, it kind of helps me wrap my brain around what I'm doing. So if I have a graph that has more than one y-intercept, it might look something like that. What's the answer to the question, you guys? Is it true or is it false? Tell me.
False.
It is false. Somebody tell me why it's false. What would happen if I had two y-intercepts? It's not a function anymore. Now it doesn't pass the vertical line test. Good. Okay, question 2. Okay, find the x-intercepts and y-intercepts. So when you do this, you guys, I need you to be really careful. And I need you to go, here are my x-intercepts. And over here are my y-intercepts. Now, Weber State is very picky about how you write the answer. You guys tell me, I want to see if you know. How are you supposed to write your answer to intercepts? As an ordered pair. Yes. On the x-intercept, the y is a 0. And on the y-intercept, the x is a 0. So I've set myself up and I'm ready to go. Which one's easier to find on this thing, the x-intercept or the y-intercept? For sure the y. Because for y, you let x be a 0. Don't write this on your paper, but this becomes a 0, this becomes a 0, and this becomes a 0. Everything's a 0, so what do I have? 0, 0. There's no work to show for that. If 0, 0 is a y-intercept, then finish my sentence. Then it's also an x-intercept. Does that mean I'm done with the x-intercepts? No. Okay, so everybody give yourself a little bit of room. Come down a little bit and write x to the third minus x to the second minus 2x, and I'm going to let y be a 0. That's how I do it, to find the x-intercepts. Okay, so look what I've got right there. Somebody tell me what to do. Take out an x. Yep, you've got a greatest common factor. So when I take out an x, I'm left with x to the second minus x minus 2. Everybody look at that line right there. This is super important. That is an incomplete sentence in an English class. That's what that line is. It's not complete. You haven't finished your thought. What's incomplete about that? Equals 0. Yes, we're solving. So it equals 0. Tell me with one word what we need to do next, everybody. Factor is correct. Good. So the x is second is going to go to an x and an x. Please don't forget your equals 0. The 2 goes to a 2 and a 1. Signs are different because it's the negative. So the 2 is the negative and the 1 is a positive. So look, guys, if this times this gives me 0, one of them has to be 0. So the x set that equal to 0 get a 0. X plus 1 gives me a minus 1. X minus 2 gives me a plus 2. Now that's not how you write your answers. Your answers are 0, 0, negative 1, 0, 2, 0, and we're done. Who says I got that? Let me see. Okay, great. Okay, right here. Let's differentiate, okay? So you have to say, here are my x-intercepts, and here are my y-intercepts. To find the x-intercept, I'm going to let y be 0. To find the y-intercept, I'm going to let x be a 0. I think right now, personally, the easiest is the x-intercepts. It's done for you. Write this down underneath it for me. X plus 1 to the second times x minus 1 to the second equals 0. I set my y equal to 0. So if I set that equal to 0, I get x equals negative 1. I set that equal to 0, I get a positive 1. People get a little panicked about the exponents, okay? Look right here for 2 seconds. You don't have to write this down. But if I wrote it out like this, with each of those squared, that would just be a negative 1 is a solution twice. You just only write it once. The positive 1 is a solution twice, but you only write it twice. So it doesn't do anything. So my x-intercepts are negative 1, 0, and 1, 0, and we're done. Okay, to find the y-intercept, you're going to let x be 0. Everybody go, f of 0 is equal to 0 plus 1 squared times 0 minus 1 squared. I would have to see that work on your paper, okay? If I write it down when I teach you, then you have to write it down when you do it. And I can see when I look at it that I can tell that's going to be a 1, and I'm done. Okay, who says I'm totally good? I get this, I feel good. Okay, great. Okay, let's do one more. And then we're going to go further. Okay, please don't just, you know what some people do, guys? They do this. Look right here and let me show you something so you don't do this. People say find all the intercepts. So then they just give me this, like over here. They'll just give me this big list. On B, they go negative 1, 0, 1, 0, and 0, 1. And they don't say which one's which. Like, which one's the X, which one's the Y. I don't know that you know unless you tell me. So differentiate those, okay? Okay, so now we're going to go x-intercept, y-intercept. And I'm going to set myself up. So to find the x-intercept, I'm going to let y be 0. To find the y-intercept, I'm going to let x be a 0. You guys, look, if I just go like this, equals 0, I'm ready to list those. So they are negative 3, 0, 2, 0, and negative 1, 0. What's the y-intercept? You have to let x be a 0. So everybody go y equals 0 plus 3 times 0 minus 2 squared times 0 plus 1 to the third, and that gives me a 12. So my answer is 0, 12, and I'm done. And you have to show that work. Okay, who says I'm good? Let me see. Okay, now listen for just a second. There's a section that's actually coming up pretty soon. I want to show you. I'm actually going to have you flip and look at it. Can I see this for a second? Okay, turn to the next section, 5.2. Is that a heavily weighted section on the midterm and the final?
Yes.
Big, right? And the next section is really equally as important. So, and that's the next lesson. Aren't those the next 2 lessons, I think? Yeah. So the next 2 lessons are super important. 5-3 kind of pulls everything all together. So what I'm about to say to you right now, if you can understand it and you're like, oh, I totally get that, that helps the next two lessons, which are super important, make really good sense to you, okay? Okay, here we go. When these x-intercepts touch the x-axis, they're either going to bounce or they're going to cross, okay? So everybody take your pencil and draw an xy axis above bounce and cross. And I want to pretend on just these two problems here, guys, that we have an x value of 2 that's a 0, or a 2, 0 as an intercept. So this is what bounce looks like, okay? So draw a picture of bounce. Let's say we're below the x-axis. And as we travel towards that intercept, it hits it, and then it bounces back down. So that's what a bounce looks like. And a cross, if you're down below, then it just crosses through like that. Okay, so that's the difference between bounce and cross. Okay, we're going to go back up to the last 3 examples, and we're going to determine if these x-intercepts bounce or cross. Okay, so here we are on A. Do you see the 0, guys? It came from here. Do you see how the exponent's a 1? 1 is odd, and odd means that it crosses. This -1 came from here. Exponent is odd, that means it crosses. X equals 2, exponent's 1, that means that crosses. You guys, does a y-intercept ever bounce? Say you had a 2 here. I'm just making it up. Would you ever hit it and bounce like that? Why not? It's not a function anymore. Never bounces, okay? Let's look at this one. The -1 came from here. The exponent's even. Even means bounce, yeah. The -1, x minus 1 gives us a 1. That's even. That means bounce. Okay, let's do the last one. So the -3 came from this guy. That's odd. That means cross. The 2 came from here. That's even. It means bounce. The -1 came from there. That's odd. It means cross. Okay? All right. Question 3. Form a polynomial equation whose real zeros are given and give your answer in factored form. So you have to multiply it out. Now it does have to be an equation. So I want everybody to go y equals. Or you could go f of x equals or g of x equals or whatever you want. Okay? So the x equals 2, that's a solution. So x equals 2 is a solution. Therefore, x minus 2 is a factor. X equals -1 is a solution. Therefore, x plus 1 is a factor. X equals 0 is a solution. Therefore, x minus 0 is a factor. Now, it's okay. The x minus 0 is pretty awkward in my opinion, because what's x minus 0? That's just an x. And where's it typical to write an x that's all alone? In the front. So let's stick that in the front. Okay? And that answer is wrong. Can anybody tell me? Say it again, honey. It has to be a 4th degree, and right now it's a 3rd. So does it tell me which one's bounce and which one cross? No. So all you're going to do is add an extra exponent to one of those, and now I've got a 4th degree, and I'm good. Okay? Okay, let's do the next one. Everybody go y equals. The +2 gives me a -2. The -2 gives me a +2. The 3 gives me an x minus 3. Am I done?
No.
What degree is that? 3. And what do I need? 5, right? So how many am I missing? 2 more degrees. So I could make a couple of them 2s, or I could make just that guy a 3, or any of them a 3, as long as you add up to 5. That's all that matters. Okay? Okay. Turning point. So I don't like to gamble because I work really hard for my money and I don't want to waste my money. And I know the odds of winning when you gamble are very, very low. I would gamble on this guy. I'd put $10 right here. I would tape a $10 bill and say, I'll bet anybody that that'll be on your final and your midterm. Probably both of them. And it's super easy. Okay. the number of turning points, all you do is take the biggest exponent and subtract 1. So if you were like this, let's squeeze in an example, like y equals x to the third minus 2x minus 4. And if they asked you the maximum number of turning points, it's so easy. It's just that biggest exponent, which is a 3, subtract 1, you get a 2. Literally, that's all you do. So it's just remembering how to do it, and that's a freebie on a midterm or a final, as long as you remember. Okay, here we go with question 4. Now, this question right here used to be on every single midterm and final. Used to be all over the place. And it's not so much anymore. So if you look at what we highlighted for the midterm or the final, that was the only thing that we highlighted. Am I correct with that? Okay, so we're going to go through and we're going to do the whole thing, but I want you to know that I think the only thing you're going to get directly from this kind of problem is the turning points. And who knows, they always change things up on me, so you never know, okay? Okay, see this question B right here? Okay, I want you to circle it, and I want you to write a note to yourself that says, do at the end. So I want you to skip it and do it at the very end of the problem, okay? And you'll see why in a second. Okay, find all the intercepts. So we've already done this, guys. Everybody go x-intercept and then y-intercept. So to find the x-intercept, you let y be 0. To find the y-intercept, you're going to let x be a 0. So guys, if y is a 0, if I just set that equal to 0, then I would get x equals 0, 2, and negative 2. So I'm going to write those as 0, 0, 2, 0, and negative 2, 0. All of the exponents are 1s, therefore they all cross. So I'm going to put a C on each of them, okay? You guys, if 0, 0 is an x-intercept, then it's also a y-intercept. Could I possibly have more y-intercepts, or am I done? I'm done. You're only going to have one y-intercept. Remember, we talked about that. So I don't have to show any work for y-intercept because I already knew I had an x-intercept of 0, 0. Okay? I'm going to skip part B, and we're going to go to C. Determine the end behavior. You guys answer this question. Is this the one, look right here, is this the one where I look at the biggest exponent and figure it out? Or is this the one where I have to add the exponents together? It is add. Thank you for answering me. Okay, so everybody go f of x equals, and then you're going to have x times x times x. Because I get an x from this guy, the x dominates here, and the x dominates here. Okay, so this is super important. Everybody write f of x equals x to the third. And you actually have to write that. See right here where it says state the power function? That's the power function right there. So make sure you write that. If you don't write that, you're going to miss it. Okay, and what is the maximum number of turning points? So the maximum number of turning points, I'm just going to go TP. Somebody tell me what that is.
2.
That's 2. Now they also want the end behavior. So they also want the arrows. So it's going to be a cubic like that, and I don't have any reflections. So my arrows are left down and right up. So you really have 3 answers on that problem, you guys. You have this power function right here. You have the maximum number of turning points, and you have your end behavior. Yes, honey?
So how do you get that there are 2 turning points?
You take the biggest exponent, which is a 3, and subtract 1. It's always what you do. Okay? Okay, let's graph this thing. So everybody go to 0, 0, and put a dot. And go to 2, 0, and put a dot. And to negative 2, 0, and put a dot. Now, I know they all cross, so if I were you, I would put the letter C right there. I always do that because then I'm reminding myself, oh yeah, it has to cross through. Okay, look at the end behavior. The left is down. So guys, we're going to be down like this, cross through, peek up, come down, cross through, peek down, swing back up, cross through. I end up, I'm supposed to end up, and I'm done. Okay, look what some people do. I want you guys to look at this and tell me why this is wrong. 2 reasons immediately you know why that's wrong.
There's not enough.
There's not a what? There's not another intercept. You can't touch the x-axis unless it's listed here, and that guy is not listed over there. There's one other way you can tell, like immediately, I know that's wrong. The maximum number of turning points. I love that, honey. You're really thinking about that. And I'm telling you, the turning points is, I think the bouncing and crossing and the turning points are the 2 biggest takeaways from this lesson for sure. So very good. There's another one. Yeah, it doesn't match your end behavior. This end behavior, that graph is down, down, and it's supposed to be left down and right up. So I can see that it's wrong. So let's go through and do it correctly. Hopefully you did it. If you already turned your page, we're not done. We're not done because we skipped part B, okay? So listen to the question. Find several other appropriate points on its graph to determine where the graph is above and where it's below, okay? So when Weber State used to ask this a lot, Weber State doesn't do the bouncing crossing thing. So they think you need to go in and plug in random values of x to see if the y is positive or negative to see where that graph is, okay? Now I want you to look right here. I have my x-axis and I have 3 x-intercepts. This is important that people miss this a lot, so you're going to want to watch. Those 3 x-intercepts have just taken my x-axis and split it into 4 pieces. Look right here. 1, 2, 3, and 4. Okay? So what part B wants you to do is to choose one x value from each of those different colored regions and figure out what the y is, okay? So I'm going to put my B right next to my graph. You guys put it in your part B, okay? So I'm just doing it so you can still see what this is. Okay, so go to part B and do an XY table. And if you need to do it sideways, do it sideways. You know, if you're restricted with your height on that thing. Okay, so that's fine. Something in the green section, like a -3. Something in the yellow, like a -1. Something in the pink, like a +1. And something in the purple, like a 3. Now, let's remember how to store these values in. Grab that calculator, okay? Everybody hit the white negative button that I'm pointing to right there. Then hit the button 3. And then hit store, which is right there where I'm pointing. And then hit enter. Now go into that equation and let's plug that in. So everybody go membar, which is right up above the store button, enter. Parenthesis, membar enter -2, close your parenthesis, new parenthesis, membar enter +2, close it, hit enter, and I got a -15. So look what Weber State is saying that you've now realized, that if you're left 3, your graph is down 15, and so we know it's down below. Guys, look at your graph. Everybody freeze right here. Look at your graph. If you did this to your graph, right there, that little piece, that's not right, because it's down all the way to a 15. So do you see how I drew mine very steep? That's what, I keep erasing that thing. That's what you guys need to do. So draw it very steep. Okay? All right, let's do -1. The next one's so easy. You don't have to punch that whole thing in, guys. Look, everybody hit negative, then hit 1, and then hit store, and then hit enter. And now you go up, up, and you see how you're back on top of the equation? Then hit enter, and I got a 3. Now, if this were my midterm or my final, I would, and my graph is not great, guys. That should be a high point right there. So I just cleaned it up a little. And then I'm going to label that -1, 3. I think it's probably smart to label it. Now everybody go 1, store, enter, up, up, enter, and you got a -3. So if I were you, I would label that point 1, -3. Let's do a 3. 3, store, enter, up, up, enter, and you got a 15. Make sure your graph is steep and you're good. Okay? It's a common mistake people make. Everybody look right here. Look at my table. I love that I'm showing you this. Let's do this, actually. What's wrong with that? How many regions was I supposed to test?
4.
4. How many am I testing?
3.
It looks like I'm testing 3. I'm not testing 3. I'm testing what? 2. Because I don't have anything from the green region. I have the -1 from the yellow. I don't have anything from the pink, and those are both from the purple region. So I'm supposed to be testing 4 regions, and I just tested 2 is all I did. Who says I see that? Okay, good. Okay, question 6. Six and 7, and then we're done. Okay, find all the intercepts. Okay, so let's make a list. Okay, so let's go x-intercept, y-intercept. Hey, let me ask you a quick question before we get started. So I told you I don't think this will be on your final or your midterm except for the turning points. Does that mean it won't be on quiz 2, which is what I make up? No. Anything in the workbook, everything in the workbook will be there because I got to make sure you know it. Okay? Okay, to find the x-intercept, you let y be 0. To find the y-intercept, let x be a 0. So y is a 0, set that guy equal to 0. I have -1, 0 bounces because my exponent's even. And I have 1, 0 bounces because my exponent's even. Look at the y-intercept. If you go 0, 1 and you don't show me any work, you're not going to get credit for the 0, 1. They require that you show, I understand I'm supposed to be putting a 0 in for x. So the work that you show would be f of 0 is 0 plus 1 squared times 0 minus 1 squared. Line your equal signs up. You got a 0, or you got a 1, pardon me, and now you're good to go. Okay? Don't do B until the end. Okay? Don't do B until the end. Okay, end behavior. So you've got an x to the second. So everybody write f of x equals. You've got an x to the second and an x to the second that's dominating. So f of x equals x to the 4th. That is an answer. That's your power function. Okay? Well, we all know that that's a parabola that's going to open up, right? So my end behavior is left up and right up. So that's my end behavior. The other question I have to answer here, which is the big question, is what's the maximum number of turning points? Everybody tell me what that is.
3.
It is 3. Good. Easy. Okay, let's graph it, and then let's go back to B. Okay, so those x-intercepts, you guys, are -1, 0 and 1, 0. And the y-intercept is 0, 1. So I'm going to come right here and I'm going to do 0, 1. I'm going to put B's by this because I know it bounces. And I'm actually going to label that y-intercept 0, 1. Okay. Now, where do I look? What do I look at right now to figure out how to draw my graph? What's the piece that's missing on this? The end behavior. Good, honey. So the left is going to be up. So the left is up. Come down, hit it, and bounce. Come up and hit that intercept. Come back down, bounce. Come up. I ended up. I was supposed to end up, and I did. Okay. Now go back to part B. I'm going to do a sideways table because I know you guys don't have a lot of room. Someone shout out how many regions I'm supposed to be testing on that graph. Shout this out. 3. Okay, look right here. I'll color them. Green, yellow, and pink. Okay, and I just choose the very next number so I make it easy on myself. Yes? Because each region separately needs to be examined to see if it goes above and below. Well, we know if it goes above and below because we do the bouncing and crossing thing. But, you know, they didn't back then. Okay, so green, -2. Yellow, 0. Pink, 2. Okay, well, I already know that if x is 0, then y is 1. I figured that out up above, so I'm just going to fill that in. Okay, now let's plug this into our calculator. So everybody go -2, store, enter. and then go parenthesis, membar, enter, plus 1, close it off, x squared. Parenthesis, membar, enter, minus 1, close it off, x squared, hit enter, and I got a 9. Now let's override that with a 2. So you go 2, store, enter, up, enter, I got a 9 as well. Now, look at my graph. Does this really look like 2, 9? If that's a 1 right there, kind of looks like 2, 3 almost, right? So I'm going to just kind of clean this up, and I'm going to go super steep, hit it, bounce it, come up, super steep, looks like that, okay? How picky will they be on that 9? I don't know, maybe not too picky, but you know what they're really picky on? Look right here. Minus every single point. I'm not exaggerating. Minus every single point. And then your teacher feels like she's going to cry. Why is that minus every single point? Look what I did. This is important. You don't want it to happen to you. Tell me. It's not a function anymore. Yeah, that thing does not swing back in. It goes out like this, and you're done. Okay, who says I'm good? I feel good. Okay, yay. Good, because I think the next ones are going to be a little tough. Yes, sir.
For B, do you want us writing them as a point or just on?
Just like that. Just like a table's great.
Okay.
Yeah.
We don't have to write it as a point. We won't get
Nope. Nope, because they're not intercepts, just intercepts. Okay, here we go. Question 7, and then we're done, guys. Okay, so x-intercept, y-intercept. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. So if it's factored, guys, I'm just going to go equals 0 like that. And then they're right there with me. So negative 1, 0 bounces because it's even. 2, 0 crosses because the exponent's odd. And negative 3, 0 crosses because the exponent's odd. Okay? Let's put a 0 in for x. So everybody go f of 0 equals 0 plus 1 squared times 0 minus 2 to the third times 0 plus 3. And I can see that that is negative 24. And you can put it in your calculator. But I can see it's negative 24. Okay, part B I'm going to skip. If you look at that equation, you guys, everybody go f of x equals the first parenthesis dominating, what am I going to get out of that? An x squared. Second parenthesis, I'm going to get an x to the third. And the third parenthesis, I'm going to get an x. So I'm just looking at the big things. X squared, x to the third, and an x.
Do you have to write that out?
No, just write down the final thing, which would be x to the, tell me everybody, 6 is correct. Is that an answer?
Yes.
Yes, it is. So then I should highlight it, right? You guys know even means parabola, and it opens up because it's a positive. So the end behavior is left up, right up, and that's it. And then turning points is probably one of the most important things on this problem. What is it, everybody? Maximum number of turning points. 5. By the way, I haven't even talked about what a turning point is. I'm sorry. I think you probably already know. Look right here. Your graph is going along and it turns. And it's going along and it turns. And it goes along and it turns. Those are turning points. Okay? Okay. So, negative 1, 0 is here. 2, 0 is here. Negative 3, 0 is there. Okay? And this is a bouncing. And those other two cross. And then the y-intercept is 0, negative 24. So I know this is not to scale, but it's okay if I label it, it's okay. So this is 0, negative 24. So now I'm safe. Even though the distance is not the same, if I label it, I'm good. Okay. And behavior is left up. So it's going to be left up, come down, cross through. I have no idea how far down to dip. Come up, hit it, bounce, come down. Now you guys are all so smart. I love it when I get to ask you a question that I think might stump you because it makes me feel like I'm actually teaching you something. Do you think that's the minimum?
Yeah.
Do you think that's the minimum point? Like, does it make sense to head up right there?
Yeah.
It doesn't, because the distance here is 3, and it's usually typical that that minimum would be right in the middle. And am I 1.5 units from that other point? No. So I'm thinking I should probably dip down a little lower and then finally come back up, hit through, cross, and there we go. Okay, now let's go back up to part B. Yes, honey?
I'm just wondering, it says that like there's 5 turning points, but like, I don't see.
So 5 is the maximum number. So like, yeah, it's just the most. Like, you know how an x to the 4th, like the maximum number of turning points would be 3. But if your equation is y equals x to the 4th, it actually just looks like that and I only had 1. So it's just the most you could have. Okay, yes, sir.
So the maximum turn point is always 1 less than the x.
Always, yeah. Okay, so this is going to be -4, -2, 1, +3, fill them in. Okay, just find the values that go with it. Have a great day, everybody. Okay? See you later. Bye, guys. Thank you. Just set it on my desk, sweetie. Thank you.